Okay, today we spent some time talking about the specific energy of channel flows, where the specific energy is defined as the local depth plus v squared over 2g, which can be rewritten in terms of the flow per width as y plus q squared over 2g y squared. So this has sort of a cubic character to it. If we multiply everything through by y squared, you can see explicitly that it's a cubic. But what I want to focus on now is just the dependence of energy with depth. And this is something that we've talked about in a series of lectures, but that's the main features that we need to point out today. So for a fixed Q, so Q fixed, we have this curve that's shown in the solid black line representing E of Y. So that's the specific energy as a function of depth. As we talked about on Wednesday, we have a critical value here, EC, and YC, which is the minimum energy possible to get steady flow. YC is Q squared over G to the 1/3, and that's equal to 2/3 times the critical energy. So that's a basic characteristic of that minimum point. Now, if the energy is greater than that minimum, so say we have some value E1, then there are two possible values of the depth, Y1, Y1 prime. Y1 is less than YC, which means the Froude number is greater than 1. This is supercritical flow. Supercritical flow has the characteristic that the fluid velocity is greater than the wave speed, which means no information moves upstream. So that's the supercritical branch that I've shown in the figure here, the lower part of the branch. The upper part of the branch has depth that is greater than the critical depth, which means the Froude number is less than 1, means flow is subcritical. Means the velocity of the fluid is less than the wave speed, and it means information moves upstream. So the result is that these two flows have very different characters. So on the upper branch, we have the red text. On the lower branch, we have the blue text. Wrote them upside down. The result is that for subcritical flow, that is Froude numbers less than 1, depths deeper than the critical depth, the flow anticipates what's coming downstream. So it's able to adjust its state as it approaches an obstruction or something in the way of the flow. Supercritical, on the other hand, does not know what's coming because no information can move upstream. The last thing I'll note is just a definition. If the normal depth is greater than the critical depth, you remember the definition of the normal depth from our previous lecture. The normal depth is greater than the critical depth, the slope is mild. If the critical depth is less than, if the normal depth is less than the critical depth, then we have a steep slope. And that simply states the fact that mild slopes have subcritical flow when the flow is uniform, and steep slopes have supercritical flow when the flow is uniform. Next lecture we're going to talk about bumps and constriction.